Hello, everyone. I'm Dr. An. NumPy is a Python library for manipulating large multidimensional arrays, which is fundamental to machine learning. This module will cover all you need to know about NumPy, which allows you to start immediately by performing machine learning and artificial intelligence tasks. Let's dive into the NumPy programming tutorial right away. Hello everyone, I'm Dr. An. Now let's dive into NumPy basics for machine learning. You can import NumPy using import NumPy SMP. SMP just means that now you can use the abbreviated MP to refer to the NumPy module. Now let's move on to creating arrays in NumPy. Array manipulation is a very basic computation in machine learning. You can create a rank 1 array, which means that an array with a single row using the np dot array function. And in the argument, you can provide a list, for example, a list containing 3 elements, 1, 2, and 3. And when you print out the NumPy array, it looks the same as a list, but actually it is a NumPy array, not a original Python list. You can create a rank 2 array, means an array with a number of rows and number of columns, by supplying in the np array function a list of lists. So here I have a list containing 2 elements. The first element is a list containing 3 elements, 1, 2, and 3. The second element is also a list containing 3 elements, 4, 5, and 6. So if you print that NumPy array, you will see that it is a rank 2 array with 2 rows and 3 columns. By the very same token, you can also create a rank 3 array. Now it takes the shape of depth, row, and column. So here I created a rank 3 array, and as you can see, it is a list of lists of lists. If you print that NumPy array, you will see that this array has 2 depths. This is the first depth, this is the second depth. So the depth has 2 dimensions. And in the first depth, it has 2 rows. This is the first row, and this is the second row. And in the second depth, it also contains 2 rows, the first row and the second row. And finally, it has 3 columns. The first column is 1, 4, and the second column is 2, 5, and third column is 3, 6 for the first depth. And for the second depth, it has 3 columns as well, 7, 10, 8, 11, and 9, 12. You can inspect the dimensions of the arrays using its attribute shape. For example, for A1, which is rank 1 array, if you take a look at the shape, it has only 1 dimension, 3, because it is a rank 1 array. Basically, it just has a single row with 3 elements. And for A2, which is a rank 2 array, you will see that it has 2 rows and 3 columns. And for A3, which is a rank 3 array, you will see that it has depth, 2 depth, and 2 rows and 3 columns. We can take a look at the length of the array, denoting the number of elements in the first rank using the len function. So len A1 is going to give you 3 because it has 3 elements in its only dimension, the only row. And for A2, it's going to give you 2 because it has 2 rows. And length A3 is going to give you 2 as well because it has 2 depths. You can also take a look of the number of dimensions or the number of ranks using the n dim denoting for n dimensions attribute. So A1 and dim is going to give you 1 because it's rank 1 array, where n dim A2 is going to give you 2 because it's rank 2 array, and n dim A3 is going to give you 3 because the 3-dimensional rank 3 array. You can also use the size attribute to know the number of elements in an array. So for A1, because it contains only 3 elements, 1, 2, and 3, so the size of the array is 3. For the rank 2 array A2, the size is 6 because it has a total of 6 elements, denoted by 1, 2, 3, 4, 5, 6. And then the size for A3 rank 3 array is 12 because it has 12 elements in total: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12. You can take a look at the data type of the array elements using dtype denoting data type. And for A1 array, the data type is integer 64 because all the 3 elements are integers, 1, 2, and 3. And a side note regarding how the integers are stored in NumPy. So integer 16 is the data type that can represent the integers from this negative number to this positive number. It is the least precise storage of the integers because any number is lower than the minimum or greater than the maximum cannot be stored in an integer 16 data type. So if you want to get more precision, more digits, you may use integer 32, which can store any integers within this range. And the most the integer 64 give you the most digits to store your integers from this value to this value. And by default, NumPy uses integer 64 data type to store integers. And you can also convert an array to a different data type. For example, convert the integer data type in A1 to float. So remember, float is the data type to store numbers with decimal points. And if you use the S type, float is going to convert all the elements in that array from integer 64 to the default, which is float 32 in NumPy. You can convert an array, NumPy array, to an original Python list using the function toList. So A1 toList is going to convert the NumPy array to a list, 1, 2, and 3. Often we create arrays to hold some results we are going to get later on from modeling. So how to create an array as a placeholder? Well, there are various ways. One common way is to create an array containing all zeros. So using the function zeros. And in the argument, you can provide the number, the dimension of the array you are going to create. So here I'm creating a rank 2 array with 3 rows and 4 columns. And as you can see, the result is a NumPy array containing 3 rows and 4 columns filled with all zeros. You can also create an array containing all ones. So here I'm using the ones function to create a rank 3 array with 2 depth, 3 rows, and 4 columns. And you can also optionally specify the data type for the elements in the array. So here I'm using the NumPy integer 16 to store those ones. And as you can see, the output is a NumPy array containing all containing all ones with the shape of 2, 3, 4, and with the data type of integer 16. You can create an array of evenly spaced values by specifying the step size using the aRange function. So aRange asks for 3 arguments. The first is the beginning value, the second is the stopping value, and the third is step size. So NP aRange 10, 25, and 5, so the starting value is going to be 10, and each time you add an incremental 5, so 10, 15, 20. But remember, the Python is last position exclusive, so therefore instead of going all the way to 25, it will stop at 20. But if you specify a different value, for example, 26, then the resulting array would be going from 10, 15, 20 to 25. You can also create an array of evenly spaced values by specifying the number of samples. So for example, here I'm using the linspace standing for linear space by providing 3 arguments. The first argument is 0, denoting the starting point, starting value, and 2 is the ending value. And then I want to get a total of 9 numbers evenly spaced between 0 and 2. So therefore, the resulting array containing 9 values, which are evenly spaced from 0 to 2. You can return an array of numbers spaced evenly on a logarithmic scale. The default base is 10. So for example, I'm using the log space function. And in the function, I provide the beginning value, the end value, and also the step size. So the resulting list of elements, the first element is going to be 10 because the default base is 10. 10 raised to the power of 1 is 10. And the last value is going to be 10 raised to the power of 3, which is 1,000. And also the numbers between. And if you want to double check whether those numbers are truly evenly spaced on a log scale, you can take the logarithmic value of the elements in the list using the base 10, as you can see that indeed those numbers generated by the log space are evenly distributed on the log scale. So 1, 1.5, 2, 2.5, and 3. You can create an array containing constant, and the argument and the function is full. And in the argument, you first provide the shape of the array you try to create. So here I'm creating an array with 4 rows and 5 columns. And also you want to provide the value of the constant you try to fill in the array. So here I want to create an array containing all 2's. So the resulting array would be a rank 2 array with 4 rows and 5 columns containing the number 2. You can create an identity matrix, which is essentially only fill in the diagonal values with 1 and all the off-diagonal values 0 using the function I. And so here I'm creating an identity matrix. So identity matrix is always going to be a square, so basically with even number of rows and columns. So therefore, you only need to supply a single argument. 5, and the resulting array is 5 rows and 5 columns. And as you can see that only the diagonal values are filled with 1, and all the off-diagonal values are filled with 0. You can create an array of random values between 0 and 1 following an uniform distribution by using the np random.random. So the first random is a submodule in NumPy, and the second random is the function that's going to create values from a uniform distribution between 0 and 1. And in the argument, you can specify the dimensions or shape of the array. So here I'm going to create an array with 3 rows and 2 columns. And as you can see that in the resulting array, it contains all the values that are randomly selected from a uniform distribution between 0 and 1. You can create an array of values that follow a standard normal distribution, basically a normal distribution with mean of 0 and a standard deviation 1, using still the random submodule in NumPy, but using the function ran_n, denoting a standard normal distribution. And you provide the shape of the array you try to create. And as you can see, the resulting array has 3 rows and 2 columns with values filled from random choosing values from a standard normal distribution. You can also create an array of random values that follow a normal distribution, any normal distribution. You just need to specify 2 additional arguments. One is log, denoting the location, basically the mean of that normal distribution. And the second argument is called scale. Basically, that's going to be the standard deviation of the normal distribution. And then you provide the shape of the array you try to create using the function random.normal. And the resulting array, as you can see, has 3 rows and 2 columns filled with randomly generated values from the normal distribution that you specify, basically the normal distribution with a mean of 1 and a standard deviation of 2. You can also copy, sort, and reshape arrays. To copy an array to a new memory, here we first generated a rank 2 array with 2 rows and 3 columns, and you want to use the copy function to copy an array. So some of you might be confused to know why we need to do the copy. Why not just assign the new array as the old array? So if you do this way, then it may have unintended consequences. For example, if you change some values in the original array ARR, and because you assign the ARR copy as the ARR, so if the value changes ARR unintentionally or maybe surprisingly to you, the values in ARR copy is also going to be changed, although that may not be of your original intention. So therefore, to avoid that behavior, you can make a copy so that this ARR copy is going to store in a different digital space than the ARR, so that in this case, if you change the values of the array ARR, the values of ARR copy will not be changed. So as you can see, the resulting ARR copy, for sure, it takes the same values as the original array ARR. You can sort an array using the function sort. So here I create a rank 1 array with 2, 3, 1, 4, 5 as the elements. And if I sort, by default, it's going to sort by the ascending value, so that the resulting array now is sorted based on the ascending order of the elements. You can flatten a rank 2 array to a rank 1 array using two options. The first option is to use the flatten command. So here I created a rank 2 array with 3 rows and 2 columns. So if I use the flatten command, it's going to convert this 2 by 3 array into a rank 1 array, basically flattening out the 2-dimensional array into just 1-dimensional. So that the values become 10, 8, 4, 2, 9, 11 in a rank 1 array. The second option to flatten a rank 2 array is to use the rebel function. And as you can see, the resulting array is, again, rank 1, same as using the flatten command. You can transpose array basically by reversing the rows and columns so that the rows become columns and columns become rows in the new array using two approaches. So here, still using the array that we just created with 3 rows and 2 columns. The first way is to use capital T denoting transpose as an attribute of the array. So the resulting array looks like this. And previously, we have the first column 10, 4, 9. Now it becomes the first row. And the first row, 10, 11, now become the first column. So basically, you reverse the rows and columns in that array. The second way to transpose an array is to use the function transpose. And as you can see, the resulting array is the very same as you call the capital T attribute of the array. You can reshape an array to 3 rows and 4 columns without changing the data elements using the reshape function. So reshape function is very versatile. For example, here I created an array with 6 rows and 2 columns. I want to reshape that array into 3 rows and 4 columns. And we use the function reshape. And as you can see here, the array has been reshaped from 6 rows and 2 columns to 3 rows and 4 columns. Here, one caveat is you need to make sure that the reshape is possible because the reshaped array has to take the same total number of elements as in the original array. Otherwise, the reshaping cannot be performed. So, for example, the previous array has a total of 12 elements because that's 6 times 2, a total of 12. And then the reshaped array also has a total of 12 elements because that's 3 times 4, so that the reshaping is possible. And now let's talk about how you can add or remove elements from array. So to append values to the end of array, we use the append function, which looks really similar as the original Python built-in append function by appending items to the end of a list. So here we have a rank 1 array taking 5 values, 1, 2, 3, 4, 5. And I want to append a value -10 to the end of the array. We use the append function. We provide the array we want to append on, and we also provide the value we want to append to the array. And the resulting array, as you can see, have -10 added to the very last position in the array. You can also insert value into an array very much like inserting values to a list in the original built-in Python command. So the insert is going to do the job. You provide the array, and also you need to provide the position where you want to insert an array, and followed by the value you want to append to array. And as you can see that the resulting array has 100 insert into position 1, index 1 in the array, and all the other elements of the array is going to be shipped right to one position. You can delete a value from the array using the delete function. So here I want to delete the second row in the array. So here you provide the array, you want to delete elements, and you also need to provide the position or the index, which row or column you want to delete. And then you also need to provide the argument regarding whether you want to delete the row or delete the column. So here I specify access equals 0, so that is going to delete the row with the index 1 from the array. So here the original array has 3 rows and 2 columns. The first row with index 0 is 10, 8. The second row with index 1 is 4, 2. And the third row with index 2 is 9, 11. And so by deleting the position 1 row, this row is going to be deleted. So therefore, the resulting array would be with 2 rows. And you can also delete the column position 1 by using the argument access equals 1. So here, the resulting array has only 1 column because the column index 1, 8 to 11, has been deleted from the array. And now let's talk about how you can combine or split an array. There are multiple ways you can do that. So first, if you want to add 2 arrays by row, you can use the concatenate function. So here we created 2 arrays. Both has 2 rows and 3 columns looking like this. And then I want to concatenate these 2 arrays by row, basically stacking the 2 arrays vertically. We use the np concatenate command to do that. You need to provide in the tuple the 2 arrays you want to stack to each other. So the first array, AR1, is going to stay in the front, and then the array 2 is going to stay at the bottom. And you need to specify whether you want to concatenate by along the rows or along the columns, because we are going to do the vertical concatenation. The array 1 stay on top and the array 2 stay at bottom. So therefore, we are going to concatenate along the rows so that the access argument should be equal to 0. And then as you see, the resulting array is vertically stacked. This is the first array on top. This is the second array at the bottom. You can also concatenate the second array and the first array together by column. So instead of doing the vertical stacking, you can do the horizontal stacking. You have the array 1 at the left and array 2 at the right. Still using the concatenate function, you provide these 2 arrays in the tuple. The only change is that now access equals 1 because you are going to concatenate 2 arrays along the column, so that access should be equal to 1. As you can see, the resulting array now has 6 rows, has 2 rows and 6 columns because these 2 arrays are stacking horizontally by each other. So you can also stack 2 arrays vertically using the vstack function. Basically, V stands for vertical. So vertically stacking these 2 arrays. And there are at least two alternatives you can use. The first alternative is use the vstack function. You just need to provide the 2 arrays in a tuple. And as you can see, the resulting array is vertically stacked on top of each other. And the second option is to use the R and then underscore. And R stands for rows, so this is the row stacking. And then you provide these two arrays in the hard bracket. And as you can see, the resulting array is vertically stacked, the same as using the vstack function. Of course, you can also stack the two arrays horizontally using the H stack. H stands for horizontal stacking. And then as you can see, the resulting array is horizontally stacked. So the second array is to the right by the side of the first array. And you can also use the C underscore. C stands for column. So and it's going to achieve the very same result as using H stack function. You can split an array vertically into 3 subarrays with equal size using the V-split. V stands for vertical, so vertical split function. And here we have an array taking 6 rows and 2 columns. And I want to equally split this array vertically into 3 arrays. So the first array would be this one, the second array would be this one, and the third array would be this one. So here in the vsplit function, we provide the array we want to split and also how many subarrays we want to create. As you can see, the resulting array is a list of 3 arrays. We can also split an array horizontally into subarrays using the H-split function. So H stands for horizontal split. So here, first we create an array taking numbers from 0 to 15 using the arange function. Remember, arange is going to start from 0, but its last number exclusive, so it's going to generate a total of 60 numbers from 0 to 15. And then I reshape that array into 4 rows and 4 columns, so the corresponding array look like this. And then I want to do the horizontal split. So basically, the first subarray is going to take the value 0, 1, 4, 5, 8, 9, 12, 13. And the second array is going to take the shape of 2, 3, 6, 7, 10, 11, and 14, 15. As you can see here, using the hsplit command, I provide the array I want to split and also know how many subarrays I want to create. The resulting output is a list of 2 arrays that have the equal size that are splitted from the original array. And now let's talk about the indexing, slicing, and subsetting of an array. So here we first created an array. It is a rank 1 array taking 10 elements in total from 0 to 9. And if I call the position 2 of that array, remember in Python, the position starting from 0. So therefore, in this array, position 0 has a value of 0, position 1 has a value of 1, position 2 has a value of 2. So therefore, x2 is going to give you the 2 as the output. And now let's change the shape of the array from rank 1 array to rank 2 array with 2 rows and 5 columns using by defining its shape. And the resulting array look like this. Now we have 2 rows and 5 columns in this new array. And to call the first row of this array, we can use x0. So x0 means that you are calling the first row of this array. So therefore, you are going to get the first row, position 0. And how about if you want to call a certain element in a row or column? For example, how you are going to call the value 5 from this array? Well, first you need to provide position for the row, and then you provide position for the column. So 5 is in the second row with row index 1. So therefore, you should supply 1 in the first dimension. And after comma, because 5 is the first element in this row, so therefore it has a column position of 0. So you supply 0 as the column index, and then x10 is going to give you the value 5. You can assign new values to an array element by just assigning that value and then call the position of that array. For example, previously you have x as an array taking those values, and then you want to assign 100 to the array element at index 1, 3. So 1 is the second row, and 3 is at position 3, so that if you count here, this is the second row, and position 3 correspond to the value of 8, right? Because that's position 0, position 1, position 2, and position 3. And you want to replace the 8 with 100. You just need to specify to assign 100 to that position in the array X. And when you print the result, as you can see that instead of having 8 in the original array, the corresponding value has been replaced by 100. You can slice the array by returning multiple elements. For example, here I want to have all the rows, but only position 2 column. So here in this array, you call all the rows. So basically both row 1 and row 2, but you only want the column position 2. So 0, 5 is the column position 0, 1, 6 is the column position 1, and 2, 7 is the column position 2. So therefore, the X, all rows, and 2 is going to give you an array of 2, 7, which is a slice from the original array X. And in this example, you want to get only the second row, row position 1. So therefore, you're going to get this row. And you are going to get columns from 2 to 5. Remember, Python is last position exclusive. So instead of giving you the column from 2 to 5, it's going to give you column from 2 to 4 instead. So this is column position 2, column position 3, and column position 4. So therefore, you get 7, 109 in the slice of the array. You can return an array with Boolean values by testing cell by cell whether each element in the array satisfies the condition or not. So here, I set a condition x less than or equal to 5. What it's going to do is going to test element by element in this array whether this condition is held. If it's held, a true is going to be the output, otherwise it's going to be false. So in this example, because all the numbers in the first row are less than 5, the condition is satisfied, so it has an output of true. 5 is also less than or equal to 5, so the first element in the second row also is true. But then 6, 7, 109, they are all greater than 5, so the condition is not held, so that the resulting cells are false. You can use the Boolean testing as a way to mask an array. For example, here I created a rank 1 array taking those values, and then I test for each element in Y whether it satisfies the condition of Y less than or equal to 3. And then I use Y in the hard bracket. I specify the condition, and then the resulting array would be only the array containing the elements that satisfy the condition of less than or equal to 3. So therefore, in this case, because 1, 2, 3, and minus 10, they are all satisfying the condition of less than or equal to 3, whereas 4, 5, 6, 7 do not satisfy the condition. So therefore, only 1, 2, 3, and minus 10 are included in this array. And now let's talk about scalar math. So scalar math is just math operations working on a specific cell, a specific element by element in an array. Here we create an array taking 6 values from 0 to 5, and I reshape it to 2 rows and 3 columns. The resulting array looks like this. And then we can add or subtract or multiply or divide out taking the power for each element in this array using the scalar math operations. For example, the NumPy add providing array and also 1 means that I'm going to add 1 to each array element, so that 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6. So the resulting array would be every single element plus 1 in the resulting array. You can also do scalar multiplication using the multiply function. So here I'm going to multiply each element of the array by 3. And you can also do subtraction and division for each element in the array. You can also power each element in the array by a certain number. So here 5. So the resulting array would be 0 raised to the power 5 is going to be 0, 1 raised to the power 5 is going to be 1, 2 raised to the power 5 is going to be 32, and so on and so forth. We can do a lot more scalar math operations. For example, here, I can take the square root of each element in the array. I can calculate the sign function of each element in the array. We can do the natural log for each element. We can calculate the absolute value using the ABS. We can also round each element in the array. For example, there are at least 3 ways that you can round a floating number into an integer. The first way to round an element is called cell, stand for ceiling. So basically, for example, if you have an element 2.5 in an array, it's going to be rounded up to 9, which is the closest integer higher than the original float number. And the second way you can round the nearest integer is to use floor. For example, if you have an element 12.8 in an array, you use the floor and you are going to get 12, which is the closest integer below the floating point number. And you can also use round function, and round is going to round to the nearest integer. So if you have 4.5, it's going to round to 5. Whereas if you have 4.3, it's going to round to 4. You can also take exponentiation of an array using the exp command. So those operations are very self-explanatory, so feel free to test them out. Besides doing scalar math, NumPy is also excellent to do vector math. So basically, vector math would be the math operations that work on 2 or more arrays at the same time. So for example, here, we do the vector mass operations concerning two arrays. We first create the first array. Again, it takes the values from 0 to 5, and we reshape it to 2 rows and 3 columns, looking like this. And we create a second array with the same shape as the first array, 2 rows and 3 columns, but all filled with number 2, so it looks like this. And then we can do the vector mass operations on these 2 arrays. So first, we can add element by elements of these 2 arrays together. Using the add function. So here, we are going to add the first element in the first array 0 to the first element in the second array 2. So 0 plus 2 is going to be 2. And the second element in the first array is 1. The second element in the second array is 2. So 1 plus 2 is 3. So on and so forth. So here you can do the vector mass operation on these 2 arrays because the 2 arrays take exactly the same shape, the same number of rows and columns. And you can also do element-wise subtraction for these 2 arrays using subtract command, or multiply 2 elements in the 2 arrays together using multiply, or do the division and taking the power of the array. So by taking the power array, you are going to have so the first array is going to serve as the base, and the second array is going to serve as the power, element by element. For example, the 0 is going to reach to power of 2, and the resulting value is 0, and 1, the 0, and then 1 is going to be raised to power of 2, so the resulting element is 1, and 2 is going to raise to power of 2, so we get 4, so on and so forth. And finally, you can also test whether 2 arrays are the same element by element using the array equal command. And so what it's doing is going to test element by element at the same position among these 2 arrays, whether the array are the same. If all the elements are the same between these 2 arrays, it is going to return true. If any of the elements between these 2 arrays in the same position is false, and then it's going to return false. So here we test whether these 2 arrays equal to each other, and as you can see that the only element in these 2 arrays at the same position that are equal to each other is 2, whereas all the other elements are not equal to each other. So therefore, the function returned false because these 2 arrays are not identical. You can also do a dot product. So if you are not familiar with the dot product, you can take a look of the Wikipedia page that tells you specifically what is the dot product. So basically, a dot product is just a multiplication of 2 arrays. So to do a dot product, you need to make sure that the shape of 2 arrays conform each with each other that allow you to do the dot product. Otherwise, the Python is going to issue an error message telling you that the shape of its 2 arrays do not conform each other, so that dot product cannot be calculated. So what do I mean by these 2 arrays have the shape conform to each other? So the dot product requires that the number of columns in the first array must be equal to the number of rows in the second array. For the dot product, the order matters. So the A1 is, say, A1 is the first array and A2 is the second array. So A1 times A2, basically the dot product of A1 and A2 is not the same as the dot product of A2 and A1. Keep that in mind, that dot product is order sensitive. So here, A1 take the shape of 2, 3. So it has 2 rows and 3 columns, and array A2 take the shape of 3, 2 and 3 rows and 2 columns. Because the A1 has 3 columns and A2 has 3 rows, so therefore their shapes conform to the requirement of the dot product so that the dot product can be calculated. So here I showcase how exactly what the number come from and how the dot product was calculated. And to calculate the dot product for these 2 arrays, you just need to use the dot function, and then you provide the arrays. Make sure that the arrays are provided based on the required order. So here, now as you see, the dot product is resulting an array with 2 rows and 2 columns. That is because the 2 rows come from the first array and the 2 columns come from the second array. Okay? And finally, I want to clarify a very confusing concept, which is access, that often confuse Python beginners. So in Python, the axis equals 0 means that we are going along the rows. Along the rows means we are going to do some calculation vertically, whereas axis equals 1 means that we are going along the columns, basically doing some operations horizontally. So let's take a look, take an example. So here we have an array taking 2 rows and 3 columns, taking values of 0, 1, 2 in the first row and 3, 4, 5 in the second row. And now first let's calculate the overall mean of all the elements in the array using the npmin command. As you can see, the resulting output is just a single scalar, a single number, 2.5, and 2.5 is the average or mean of all 6 elements in this array. But how about if I want to calculate the mean for each column? So presumably you would think that I should use the argument axis equals 1, but actually that is not true. Remember that axis equals 0 means you are going to go along the rows. And because the goal for you is to calculate the mean for each column, so a mean for column 1, a mean for column 2, a mean for column 3, and a mean for column 4. And therefore, actually, when you calculate the mean for column 1, for example, you are go along the rows. You are going to go vertically for all the elements in the first column. And similar, if you want to calculate the mean for column 2, you're also going to go vertically along the rows. So therefore, if you want to calculate the mean for each column, you should specify axis equals 0 rather than axis equals to 1. You can confirm that by using the npmin, providing the array and also axis equals 0. And as you can see, the output is a rank 1 array with 3 elements. So 1.5 is the mean of 0 and 3, the first column. 2.5 is the mean of the second column, 1, 4. And 3.5 is the mean of the third column, 2 and 5. By the same token, if you want to calculate the mean for each row, you should go along the column. So basically, in this case, if you want to calculate the mean for row 1, you go along the column, basically go horizontally, so that the axis should be equal to 0. So the axis should be equal to 1 instead. So in this case, for example, you use npmin array and axis equals to 1. The resulting array is rank 1 array with 2 elements. So 1 is the mean of the first row, 0, 1, 2. And 4 is the mean of the second row, 3, 4, 5. So therefore, if you want to calculate the mean for each column, you should specify axis equals 0 because you are going to go vertically. Whereas if you want to return the mean for each row, axis is equal to 1 because you are going horizontally. And finally, you can calculate the cumulative sum using the sum function. Again, if you want to calculate the cumulative sum for each row, you should specify axis equals 1. If you want to calculate the cumulative sum for each column, you should specify axis equals 0. For example, here, this is the original array, and you want to calculate the cumulative sum for each row. So the cumulative sum is calculated this way. So 0, the cumulative sum of 0, because 0 is the first element, so it's still 0. And then 1, you are going to add the first element, 0, and also 1 together, so it's 1. And for the third element in the cumulative sum, it's going to be 1 plus 0 plus 1 plus 2, so get 3. So this is how you calculate the cumulative sum. And hopefully by now, you should have a fairly good understanding of what axis equals 1 and what axis equals 0 mean. And now let's take a look at how you can calculate the correlation coefficient matrix of two arrays. Remind you that the matrix takes the following form. In the diagonal, you have the correlation coefficient of the array with itself, and on the off diagonal, you have the correlation coefficient between these two arrays. So here we created two arrays. Both are rank 1 array with a total of 10 elements. The first array is take the elements from 12 to 50 evenly spaced, and the second array take randomly selected values from a uniform distribution between 0 and 1. And you use the CORR, COEF command stand for correlation coefficient, and you provide these two array name as the arguments. And now the resulting array is the correlation coefficient of the two arrays. That brings the end to today's module on NumPy basics for machine learning. Thank you for your attention, and I'll see you next time.